about trigonometric functions and their domain and range. We have discussed the domain and range of sine is. These things, this concept over here are very important. You have already learned this concept in class 11. So you should know that domain, just a second, domain of sine function is all real number, and range lies between -1 to 1. Similarly for cosine, for tan function, the domain is all real number minus the odd multiple of pi by 2, as we have discussed in the previous class, because it is sine by cos. So we will exclude all those points where the cos is 0, because in denominator 0 is not acceptable. There the function will not be defined. That's the domain, and range will be all real number. Cot, same concept, all real number minus, since cot is equals to cos by sine, so we will exclude all those points where the sine is 0, and we know sine is 0 at n pi, where n is an integer. So integral multiple of pi, sine is 0. Just a second. Very interesting topic. Yeah, and range is all real number. Now sec, all real number minus odd multiple of pi by 2, because again sec is 1 by cos, and range is all real number minus -1 +1, or we can also write it as this one can be written as -infinity to 1 union this one -1 union 1 to infinity. Okay, so we will, whatever number you will be just giving as a domain, your output will always come out towards the left of -1 and towards the right of 1. You will not get any number in between -1 to 1. Okay, now cosec, same concept. This one also can be written as, the range can also be written as -infinity to -1, just like the sec one, and 1 to infinity. Okay, now here we are going to discuss about inverse trigonometric function. So that is sine inverse x, cos inverse x, tan inverse x. So here the domain and range of these functions are, these are the domain and these are the range. So for sine inverse x, domain lies in between -1 to 1, and range is minus pi by 2 to pi by 2. We also call it as a principal range. Okay. For cos inverse x, domain is the same, just like the sine one, and the range is 0 to pi. This is also called the principal range. Okay. The sine inverse x, cos inverse x, this inverse trigonometric function, when we will draw the graph, it will not be a function only. That's why these ranges are defined, that in this range it's behaving like a function. In this range, apart from this, there are all different ranges also, in which this inverse trigonometric function behaves like a function. But this is the principal range which we have to take in consideration. Now the next one is cot inverse x. Domain is all real number. Range lies between 0 to pi. Sec inverse x, just like the previous one. There, whatever was the range, that will be the domain over here. And the range will be cos 1, cos inverse x, 0 to pi. That we have taken minus pi by 2. Again, 0 in the denominator. We don't want to take those points. Cosec inverse x, same concept. Now here you should know one more concept you must have learned in class 11, that this is the x-axis and this is y-axis. We also the concept of unit circle. Okay, we can draw unit circle over here. This is 0, this is pi by 2, this is pi, this is 3 pi by 2, and then again this one is 2 pi. Okay, not degree, in radian. Now on the x-axis on this line, no transformation occurs. And on the y-axis, transformation occurs. What exactly is the meaning of this? I am telling you, just wait for a bit. Transformation occurs. Now on the if we will take the angle as sine pi by 2 minus theta, cos pi by 2 minus theta. This one was very simple and you must have learned that pi by 2 minus theta will be cos theta, right? So in the first quadrant, all are positive. In the second quadrant, sine is positive. In the third quadrant, tan is positive, and in the fourth quadrant, cos is positive. So what's the meaning of transformation occurs and no transformation occur? If you already know, well and good. If you don't know, this is just the recap of the previous concept. So this pi by 2 minus theta, with the help of this one you can understand. However, we will be taking for another angles also. So pi by 2 minus theta at pi by 2 on the y-axis, transformation occur. That means sine will change to cos. So that's why sine changed to cos. Now we are also worried about the sign. Sign means whether it will be positive cos, whether it will be negative cos, or what. So pi by 2 minus theta, it comes in the first quadrant, and in the first quadrant this sign is positive. All are positive and sign is also positive. That's why it is giving the result as a positive cos theta. Okay, now if you want to do for sine pi minus theta, okay, so pi minus theta, here we know, just a second now. Yeah, or before pi minus theta, pi by 2 plus theta, let's take. If we will take pi by 2 plus theta, cos pi by 2 plus theta, tan pi by 2 plus theta. Similarly, cot pi by 2 plus theta. So here sine pi by 2 plus theta, it comes in the second quadrant. Pi by 2 plus theta means more than pi by 2. It comes in the second quadrant, and in second quadrant sine is positive. So whatever this sine will give the result, whatever it will give the result, that will be positive, because in second quadrant sine is positive. Now pi by 2 plus theta, pi by 2 comes on the y-axis, and on y-axis I have written over there on the screen, transformation occurs. That means it will change cos theta. Okay, similarly cos pi by 2 plus theta, in the second quadrant pi by 2 plus theta comes, and there in the second quadrant this cos is negative. Okay, so whatever result it will give, whatever output it will give, the result will be negative, because cos is negative in the second quadrant. And obviously pi by 2 transformation occurs, so cos will change to sine. Here tan pi by 2 plus theta is there. Again pi by 2 plus theta, second quadrant tan negative. The result it will give will be negative. Now transformation occurs, tan will change to cot. Cot pi by 2 plus theta, same way. It comes in the second quadrant cot will be negative, and transformation occur at pi by 2. So we can see it will be tan. Now sec and cosec. Same way we have to do for sec and cosec also. Okay, now the next one, the next angle is sine pi minus theta, cos pi minus theta. Okay, I'm not writing all. Okay, just tan, sine. These three I'm writing. On the basis of these three only you can do the other three also, or you can understand. Okay, whenever we have to use, we'll be using this concept. So pi minus theta, that means you can see this is pi, here pi. Okay, and here beside pi I have written no transformation occurs. Okay, on the x-axis, no transformation occur. That means sine will remain sine, cos will remain cos, and tan will remain tan. But what about the sine? Okay, sine will remain sine theta, tan will remain tan theta, and cos will remain cos theta. But what about the sign in front? Whether it will be positive sine theta, whether it will be negative sine theta, whether it will be positive tan theta, negative tan theta. Same way, positive cos theta, negative cos theta, what? So in the, again, pi minus theta comes in the second quadrant. In second quadrant, sine is positive. So our result, this sign is positive, so whatever result it will give, it will be positive. In the second quadrant, tan is negative, so the result whatever it's giving, it has to be negative. In the second quadrant, cos is negative, so whatever result it will give, that will be negative. Okay, similarly we can understand for sine pi plus theta also. Now who will tell me what will be the value of sine pi plus theta, cos pi plus theta, and tan pi plus theta? Yes, who is gonna tell me? Sin pi plus theta will be, this concept you have already learned in class 11. This is, however, just the recap. That's why I'm taking it quickly so that we can start solving the questions from here. Sin pi plus theta will be, you can answer in the chat box also. Anyone? Deborah, Austin, Faza,
Ma'am, minus sine theta.
minus sin theta. Yes, it will be minus sin theta. Tan pi plus theta will be, anyone? See, pi plus theta comes in the third quadrant. In third quadrant, tan is positive. Okay, so whatever result this tan will give, that will be positive. We don't know whether that will be tan or cot. We don't know. But it will be positive because in the third quadrant, tan is positive. Now, pi plus theta, you can see pi lies on the x-axis. Okay, I'm talking about this part. Whoever have joined late, 0, pi by 2, pi, 3 pi by 2, 2 pi. Okay, on the x-axis I have written no transformation occurs. On the y-axis I have written transformations occurs. Okay, so pi plus something, pi minus something comes, as you can see, pi plus or pi minus, pi is sitting on the x-axis and there no transformation occurs. That means it will not change, tan will remain tan only. Cos will change. Here cos, this comes in the third quadrant, and in third quadrant cos is negative. This will give the result negative. Now no transformation occurs, that means it will be minus cos theta. Is it clear to everyone? You already know that, right? Right? Because I have seen most of the student struggling with this part. However, this part was there in class 11, but while solving the question, this is something which will create confusion. That's why I am discussing it over here. Now, sine 3 pi by 2 minus theta, cos 3 pi by 2 minus theta. Same concept we are going to apply. 3 pi by 2, as you can see, the sky shaded part, the sky highlighted part, that is sitting on the y-axis. On the y-axis, transformation occurs. Okay, I have written on the top transformation occurs. So 3 here, here. Okay, so 3 pi by 2 minus theta, it will change. Sine will change to cos. That we know. Now whether it will be positive cos or negative cos, we have to see the quadrant. So 3 pi by 2 minus theta, that means it will lie in the third quadrant, and in the third quadrant sine is negative, cos is negative, so the result it will give as a negative. This sine will give the result negative and this cos will give the result negative because it is in the third quadrant, and transformation occurs, that means cos will become sine. Okay, so this is the concept. Let's start solving the question from inverse trigonometric functions. The first question is sine inverse minus 1 by 2. Okay, find the principal value of the following. So we have to find the principal value of this given expression, you can given trigonometric function. Okay, so what will be the principal value? We can assume sine inverse minus pi by 2 as x. So from here we can say sine x is minus 1 by 2, right? Now 1 by 2, which angle gives 1 by 2 for sine function? Anyone? I'm not talking about minus 1 by 2. First thing first, tell me 1 by 2. Which angle gives us 1 by 2? Yes.
Ma'am, sine 30.
That means pi by 6,
Yes,
right?
ma'am.
So I'm going to write it as a minus sine pi by 6. Okay. Now, inverse trigonometric functions, this one's principal value we have to find. Now only when I started the class, I have discussed the domain and range of inverse trigonometric function. Okay, so you can see inverse trigonometric function range is minus pi by 2 to pi by 2. Whatever answer we must get, that whatever answer we are going to get, that must lie in between minus pi by 2 to pi by 2. That is called the principal range. Okay, so it must lie in between minus pi by 2 to pi by 2. That's called principal range. Whatever angle we must get from here, that must lie in between minus pi by 2 to pi by 2. Where is minus pi by 2? So this is 0. If we will go over here, this direction, here we will be having minus pi by 2. And if we will go in this direction from 0, it will be pi by 2. Okay, so whenever we are moving clockwise direction from 0, we are getting minus pi by 2, anti-clockwise direction pi by 2. So in this range only we have to find the angle. Now here fourth quadrant, first quadrant. In fourth quadrant we know 2 pi minus theta comes, right? So this pi by 6 can be written as 2 pi minus pi by 6. Now only we were talking about the trigonometric function, the transformation of angles and everything. So you can, let me write it over here. Sine 2 pi minus pi by 6. What will be the result? So 2 pi, it comes on the x-axis, and on x-axis now only I was telling you, on x-axis no transformation occurs. Sine will remain sine only. So the result will be sine pi by 6. Now the concern is whether it will be positive sine pi by 6 or negative sine pi by 6. So 2 pi minus theta comes in the fourth quadrant, and in fourth quadrant sine is negative. So this sign will give the result negative. Whether transformation occurred, not occurred, that is one thing we have to think. about. And the other thing we have to be careful about is what will be the sign, whether it will be positive sign or negative sign. So here it will be negative sign. So as you can see here, minus sine pi by 6 can be written as sine 2 pi minus pi by 6. Minus sine pi by 6 can be written as sine 2 pi minus pi by 6. I am going to write it. This one can be written as sine 2 pi minus pi by 6 sin x is equals to, or we can also write sin x is equals to sine minus pi by 6. Sine of minus theta is also sine theta. Sine of minus theta is minus sine theta. That also we know. So that also we are writing it. Okay. Now this one will give sine 6 2 times 12 pi minus pi, that means 11 pi by 6 sin x. So this is giving us x value as a 11 pi by 6, and this will giving us x value as a minus pi by 6. Now we have to check which value is lying in this principal range. What is the principal range? This minus pi by 2 to pi by 2, this is the principal range of sine inverse x. Okay, so minus pi by 2 to pi by 2 means minus 90 to 90. Here 11 pi by 6 means 11 into 180 by 6, that means 330. It is not lying in this range. 330 minus 90 to 90 के बीच में lie नहीं करता है. Okay, so we cannot take 330. We cannot take 11 pi by 6 as an answer. So what will be the answer? Minus pi by 6. Let's check it. Minus pi by 6 means minus 180 by 6. That means minus 30. Minus 90 से 90 के बीच में minus 30 लाई करता है. So yeah, we can take minus pi by 6 as the answer. This is our answer. X equals to minus pi by 6. Okay. This is our principal value for the given inverse trigonometric function. Let's do a few more questions. If we are having tan inverse minus root 3. Now again we'll be doing the same thing. Tan inverse minus root 3 is equals to x. Tan x is equals to minus root 3. You must learn the domain and range of inverse trigonometric function. Okay, you have understood the concept, but you should learn it also. So tan inverse x, the range or the output must be lying in between minus pi by 2 to pi by 2 open interval over here. Okay, so whatever result we are going to get from here, that must lie in between minus pi by 2 to pi by 2. Our x must be lying in this range. Okay, let's check. Root 3. Which angle gives us root 3 for tan function? कौन सा एंगल रूट 3 वैल्यू देता है? tan 30 degree, tan 45 degree, tan 60 degree, tan 90 degree, tan 0 degree, what?
Ma'am, 60.
60. That means pi by 3,
Yes,
right?
ma'am.
So tan x is equals to minus tan pi by 3. Here also we have to think about like what will be the, like what can be taken. Here also we know the range is minus pi by 2 open interval and to pi by 2 open interval over here. Okay, from this range only we have to choose the x value. Okay, now uh, here also we can think about 2 pi minus theta. As we can see, fourth quadrant is there. So if we will think about 2 pi minus theta, tan 2 pi minus pi by 3 will be 2 pi minus 2 pi. No transformation occur. Tan will remain tan. Now plus tan pi by 3 or minus tan pi by 3, that we will decide according to the quadrant. Fourth quadrant mein tan is negative. Okay. So obviously it will give the result negative. So yes, minus tan pi by 3 can also be written as tan 2 pi minus pi by 3. And yes, just like the previous case, here also one more possibility we can take as a tan x is equals to tan of minus pi by 3. Okay, here whatever this minus sign you can see, this I have taken with the angle. Okay, first case, second case, because tan of minus theta is minus tan theta. Now from here we are getting 2x value. One of them is 3 2 times 6. Pi minus pi will be 5 pi by 3. If you will do the calculation, you will get 5 pi by 3. Here you will get x equals to minus pi by 3. अब इन दोनों वैल्यू में से देखना है कि कौन सा हमारा प्रिंसिपल रेंज में एग्जिस्ट करता है. Okay, what is the principal range? Open interval minus pi by 2 to pi by 2. That means जो भी minus 90 से 90 के बीच में लाई करेगा वही वैल्यू हम लोग ले सकते हैं. So let's check. 5 into 180 by 3 means 300. Minus 90 to say 90 के बीच में 300 doesn't lie. Okay, so we cannot take this 5 pi by 3. Minus pi by 3 will lie, and yes, that is the answer. X is equals to minus pi by 3. So always we have to take the consideration of all the possible cases. Okay, let's do a few more questions. Very basic question. Sec inverse 2 by root 3. So let's assume sec inverse 2 by root 3 is equals to x. So sec x is equals to 2 by root 3. Which angle gives us 2 by root 3 for the sec function? For the second function? Quickly. कौन सा एंगल 2 by root 3 वैल्यू देता है? Who will tell?
Ma'am, 30.
Yes, 30 degree, yeah. Cos 30 root 3 by 2, sec 30 2 by root 3, 30 degree. That means sec x is equals to sec pi by 6. Okay. So, and the principal range for sec, if you have learned this table, you can see over here, it is 0 to pi minus pi by 2. Okay, pi by 2 we cannot take that because that is making cos as a 0 and the function, inverse function, as a undefined. So 0 to pi we can take any value from 0 to pi but not pi by 2. Okay, so 0 to pi means 0 to 180 we can take any value but not 90 degree. Okay, pi by 6, as you know, as you have just said, it is 30. So yes, it is lying in between 0 to 180. X is pi by 6. This was very straightforward. Okay, always you have to check whether your answer is lying in that range or not. Okay, now the next question is, a few things you must know over here, that if we are having sine inverse sin x, or we are having sine of sine inverse x, or we are having cos inverse cos x, or if we are having cos of cos inverse x. Yeah, just let's understand with the help of this examples only. So as you know, here the result will be x, here also the result will be x. Please don't think that these two are cancelling out each other. No, it doesn't cancel. According to the concept, it we will get x. Okay, here also we will get x, here also we will get x. Okay, now sine inverse. Just a second. Here we are having sine inverse of sine x. Okay, sine inverse will always give the output, or the range of sine inverse will lie in between the principal ranges minus pi by 2 to pi by 2. So here whatever x will be there, that will always lie in this range minus pi by 2 to pi by 2. Okay, this total is giving us x, and the sine inverse is having this principal range. That's why our x will always lie in between minus pi by 2 to pi by 2. For the next one, sine of sine inverse x, so here we will think about this sine function. Sine function always gives the, like, the range of the sine function is minus 1 to 1. So here x value will lie in this range only, minus 1 to 1. Okay, because this is the range of sine function. Similarly, cos inverse, we know the range of this inverse function cosine is, here x will lie in between in this range 0 to pi. And for cos, again x will lie in the range minus 1 to 1. So we have to be careful what function we are having. Our uh, Accordingly we will get the principal range or principal value. Okay, which will be based on the principal range. We have to be careful with the range, sine function, cosine function, domain range. We have to, you should be careful with the, like, if you are getting the output, that output must lie in the principal range only. Now here a few simplification based questions are also there. So if we are having one question as tan inverse cos x by 1 minus sin x, where x lies in between 3 pi by 2 to pi by 2, simplify it. Okay, so we are having this concept is, like, here where you are learning the concept of simplification. Now you must have, if you have, like, done the integration chapter, differentiation chapter, there you have seen this concept. We, like, while doing the integration, we always try to simplify, we always try to substitution and all. So this is the chapter which is preparing us for doing the calculation, for doing the simplification over there. Okay, so if we are having tan inverse cos x by 1 minus sin x, our our motto is to convert the whole thing, this whole thing, in tan. Okay, so the tan inverse of tan will be only x, we will get the answer. So we are trying to make it as a tan. How we can do so? So we can see here cos x, cos 2x formula is cos square x minus sin square x, right? And two more formulas are there. Who will tell me? For cos 2x, we are having three formulas. What are those? Anyone? Cos 2x formula which was there in class 11.
Ma'am, 1 minus 2 sine square x.
Perfect. And 2 cos square x minus 1, right?
Yes, ma'am. Yes, ma'am.
Okay, these are the three formulas which can be used for cos 2x. Here we don't have cos 2x, we have cos x. No worries, we can customize the formula. We can use the same formula over here. So we are going to use tan inverse. Here it will be, when 2x was there, we have written cos x cos x. When x will be there, the other side will be taking x by 2, cos square x by 2 minus sin square x by 2. So I am going to write over here cos square x by 2 minus sin square x by 2. Okay. Now the denominator 1 minus sin x. So I am going to write it as a sin square x by 2 plus cos square x by 2. The identity, the very first identity, sin square theta plus cos square theta is 1. So 1 I am going to write it like this. Minus sin x can be written as 2 sin x by 2 cos x by 2. Here also I have applied the formula of sin 2 theta. 2 sin theta cos theta. Okay. This is the whole thing we are having over here. Now the numerator, as you can see, it looks like a formula of a square minus b square. So we can write it as a plus b, like cos x by 2 plus sin x by 2. And quickly we can write it as a cos x by 2 minus sin x by 2. And the denominator, it looks like a formula again of a minus b whole square. So the denominator can be written as sin x by 2 minus cos x by 2, that's whole square. Okay, tan inverse we are still having outside. Now tan inverse this sin x by 2 cos x by 2 can also be written as cos x by 2. A minus b whole square or b minus a whole square is the same thing. Okay, because why I'm telling that it's the same thing, because here if you will take out minus common and it will become b minus a. When you will be doing the square, again this minus will be positive and it will become b minus a whole square only. So due to the power 2, a minus b whole square and b minus a whole square is the same thing. Okay, so by expanding any one of them, you are going to get a square b square positive and 2ab negative. Okay, so I am going to write this one as cos x by 2 minus sin x by 2 whole square, because sin x by 2 minus cos x by 2 or cos x by 2 minus sin x by 2 whole square, due to the square, it's the same thing. Okay, so this one and this one will get cancelled out. I have written this one as a this one, don't get confused that there is a denominator over there, no. So we are getting cos, oh, sorry, I have cancelled the positive one. We need to cancel out the negative one, this one with this one. Okay, and this one I have written like this one. So we are having cos x by 2 plus sin x by 2 over cos x by 2 minus sin x by 2, which can be written as tan inverse. Now if we will divide numerator and denominator by cos x by 2, we will be getting 1 plus tan x by 2, 1 minus tan x by 2. If this step is not clear to you, please let me know. I am dividing numerator and denominator over here with cos x by 2 like this, like this, like this, and like this. And that's how we are getting the next step. Now the next step can be written as tan pi by 4, that is 1. So this one can be written as tan pi by 4, tan 180 by 4, if you know, 45 degree, and that is 1 only. Okay, plus tan x by 2 by tan a plus tan b by 1 minus tan a tan b. That's what we are trying to make, so that we can write the formula of tan theta. What formula we can write from here? Tell me. Tan A plus tan B by 1 minus tan A tan B. This is the formula of tan. Anyone? A plus B? You know that, right? So this is the formula of tan A plus B. We can write it as a tan inverse, and here tan pi by 4 plus x by 2. Now as you know tan inverse tan, the result will be only pi by 4 plus x by 2. And we are done. Okay, we are done with the solution. Any confusion over here?
No, ma'am.
Let's move ahead. If we are having cot inverse 1 by under root x square minus 1, where x is greater than 1, obviously we have to write it in simplest form. What to do over here? What can be taken as a substitution, so that like cot inverse is there, so we want to make it cot over here. How can we do so? Anyone? This simplification, like I believe this part is easier for you
X
since you
is
have already
equal to sine inverse.
uh, x as a substitution of x can be taken as.
Sine inverse.
So you are saying if we will take sine inverse x over sine inverse theta over here, that will help us to reach at cot theta over here. To reach at cot over here, the whole expression will be become cot. Is it so? Is there any formula? Sine inverse theta whole square minus 1. Inverse you are saying, or only sine you are saying?
No, only sine theta.
We will take only sine theta. Is it? Let's see whether it's going to help us or not. So if we will take x as a only sine theta, so sine square theta minus 1. Now in class 11 you have learned about complex numbers. So here if we will take out minus common out, and if we will make it 1 minus sine square theta, so that it will give the result cos square theta, there will be 1 minus which will come inside the root, and that will give us imaginary number. Okay, so we don't want to create negative inside the square root, right? Right?
Yes.
Yes, ma'am.
This may not work over here. What about the other guess? We are having three identities. Sine square theta plus cos square theta is equals to 1, which didn't work. The next one was sec square theta plus tan square theta is equals to 1. The next one is cosec square theta plus cot square theta, not plus, minus, here also minus, cot square theta is equals to 1. So now we have to check for the second one and third one. If we will be taking second one, that is uh, x as a sec square theta, as sec theta. If we will take x as a sec theta, let's see whether it is working or not. Okay, this three identity only we are having in hand, and yes, we have to apply trial and error method, because like this is how we can solve the problem. Okay, so sec square theta minus 1. From here we can see sec square theta minus 1 is tan square theta. Okay, so maybe it seems like it will work over here. Let's see. X is sec theta. Okay, so we are having 1 by, okay, one more thing I forgot to mention. previously. No, I have mentioned already. So here we are having sec square theta minus 1, which will be tan square theta inside the root, and outside we are having cot inverse. Cot inverse outside and 1 by tan only inside. So we are having cot inverse and 1 by tan is cot. And yes, we are done. Theta. Okay, that is, now we have to substitute, do the back substitution. So here x is equals to sec theta, we have assumed x equals to sec theta, we have assumed, so theta will be sec inverse x. That is our answer. Is it okay?
Yes, ma'am.
Now the next one is, this one is very simple. 3 sine inverse x. Proof, we have to prove it that 3 sine inverse x is equals to sine inverse 3x minus 4x cube, where x belongs to minus 1 by 2 to 1 by 2. What to do over here?
X is equal to sine theta.
Yeah, we will be taking the right hand side and let's substitute x equals to sine theta over here. X equals to sine theta. So sine inverse 3 sine theta minus 4 sine cube theta, and this is the formula of sine.
Sine 3x.
Exactly. Sine 3 theta. So 3 theta only we will be getting, and theta we will be replacing now theta with sine
Sine
inverse.
inverse x.
And this is how we are done with the left hand side part. Let's take one last question. Tan inverse under root 1 plus x square minus 1 by x naught equals to 0. Okay, so here uh, we have to simplify it. Okay, we have to think what can be taken as a x. We are having three identity in hand: sine square theta plus cos square theta is equals to 1, sec square minus tan square 1, cosec square minus cot square 1. So from there, any identity we can use over here to simplify, so that this square root will vanish and we will end up getting tan inverse tan of something. Okay, so what can be written over, taken over here? X as a
Cos theta.
cos theta. Let's see whether it's working or not. So here only, just the quickly we have to see. So 1 plus cos square theta, is it so? 1 plus cos square theta. We are not able to simplify it further because 1 minus cos square theta is sin square theta. Okay, so cos is not working. Can you see? The other two identities we are having, sec square theta minus tan square theta is equals to 1, and cosec square theta minus cot square theta is equals to 1. So the other identity, if we will try to use over here, so 1 plus x square, if we will take 1 plus x as a tan theta only, if I am taking, so 1 plus tan square theta it will become, that means sec square sec theta will come out, and in the numerator we will end up having sec theta minus 1 by x we have taken as a tan theta. So will it, like after simplifying this one, is it possible to get tan theta? Because outside we are having tan inverse, so inside the bracket we must get tan, right? So here we are having tan inverse of this one. Let's check sec theta minus 1 by tan theta. Can we get tan from here? Just tan. So sec theta means 1 by cos. minus 1. Tan theta means sine by cos. Outside tan is already there. Okay. So we will be having 1 minus cos theta in the numerator and only sine theta in the denominator. That's it. This cos will cancel out each other. And if you are wondering how I got 1 minus cos theta, I have done the simplification over here directly. Okay. You can show the step over here. You need to show the step over here. Now 1 minus cos theta. Now only we were discussing the formula of cos 2 theta. And 3 formula we have written over here. As you can see. Cos 2 theta formula is cos square theta minus sin square theta. 1 minus 2 sin square theta and 2 cos square theta minus 1. From this 3 formula we will be using one of the formula so that this 1 will get cancelled out. Okay. So the formula we have written as 1 minus 2 sin square theta and 2 cos square theta minus 1. From this 2, we'll be using 1 so that this 1 will get cancelled. Here 1 is positive. So obviously we need a negative 1. So the first formula will give us the negative 1. Okay. So let's substitute it. Tan inverse 1 minus, if we will write the first formula, so it will be without bracket also I can write, but to show you I am writing it with bracket. 2 sin square theta by 2 by again 2 sin theta by 2 cos theta by 2. Okay, so tan inverse 1 minus 1 plus 2 sin square theta by 2 over 2 sin theta by 2 cos theta by 2. Okay, now this 1 and 1 will get cancelled out. 2 and 2 will get cancelled. Sin theta will get cancelled. Sin theta by cos theta by 2. We will be having tan inverse tan theta by 2. Can you see? And hence we got theta by 2 as an answer. What is theta? We have taken theta as a tan theta. Okay. That means theta we have taken, x we have taken as a tan theta. So theta will be tan inverse x. Is it clear? Is it clear? Is it clear to everyone?
Yes, ma'am.
Okay. Let's take few more questions. Okay. So one of the question is tan inverse cos x minus sin x over cos x plus sin x. And here x lies in between minus pi by 4 to 3 pi by 4. Okay. Here also we have to simplify it. Okay. Now what can be done over here? Tell me. This is something just now we have solved. If you will get back to previous question, can you see here we have got tan inverse of this by just one of the term. I want to say can you see this step? This one. Tan inverse of this one. The way we have solved from here. Now our next question, the question which we have taken just now is exactly like this one. Okay. So if you will see, just see the construction over here. It is tan inverse cos x by 2 plus sin x by 2 over cos x by 2 minus sin x by 2. Okay. here we are having tan inverse of cos x minus sin x by cos x plus sin x. Okay, so basically we are having the arrangement just like the above one. If exactly not just like that, then maybe like it's like that only, and from here we have to simplify. What we have done over there, we have done the division like in numerator, in denominator. What we want tan over here. Okay, we need tan over here. So what to do over here? Anyone?
Divide all the terms by cos x.
Divide numerator and denominator by cos x. Exactly. So we'll be having tan inverse. If we will divide by cos x, it will be 1 minus tan x over 1 plus tan x, and this can be taken as tan inverse. Now again pi by 4 plus pi by 4 minus tan x over 1 plus tan pi by 4 into tan x. And can you tell me what formula is this? Tan A minus tan B by 1 plus tan A tan B.
Tan A minus tan B. Like,
Tan A minus B. Tan of
yes.
A minus B, right? Or A minus B, whatever you say, right? So it is tan of pi by 4 minus x. And outside tan inverse, still we are having. So we will end up having pi by 4 minus x. Have we done any substitution over here? No. So this is our answer. Okay. Let's take if we are having tan inverse 3a square x minus x cube over a cube minus 3a x square. Okay, where a is greater than 0, x lies in between minus a by root 3 to a by root 3. What to do over here?
Substitute x by a tan theta.
A tan theta, exactly. If we will substitute it a tan theta over here, here only I am showing so that we can do it quickly. So here we'll be having a square into a tan theta minus a cube tan cube theta. Here also a cube minus 3a into a square tan square theta. So a cube will be getting in the numerator each and every, the first term, the second term, both will be having a in the numerator. The first term and the second term both will be having a in the denominator. A cube we can take out from the common, we can take out from the numerator and the denominator, that will get cancelled, and the formula will be having, it will be the formula 3 tan square theta minus tan cube theta over 1 minus 3 tan square theta, which is a formula of tan 3 theta.
Tan 3.
Yeah. So we'll be having 3 theta directly from here. Now there is one question which says that cos inverse cos of 7 pi by 6 is equals to, this is MCQ question. Okay. Option A 7 pi by 6. Option B 5 pi by 6. Option C pi by 3. And option D pi by 6. Which option is the correct option? Anyone? Anyone from here? Which option is the correct option? A. Cos inverse cos is 7 pi by 6. Is it so? Yes. Let me know what exactly are you thinking. Will it be 7 pi by 6 or no?
No.
Why? Why? Why it will not be 7 pi by 6? Anyone? Any idea why it will not be 7 pi by 6? Let's see. Now only we were discussing one concept where I was telling you that whenever we are having such arrangement, cos inverse of something, the x value or the theta value must be lying in this interval. Okay, 0 to pi. That means 0 to 180. 7 pi, what we are having over here? 7 pi by 6. That means 7 into 180 by 6, 210. The range is 0 to pi. That means 0 to 180. Our answer must be lying in this range only. And 210 is not lying in this range. So obviously, yes, you said it right. Perfect. It will not be 7 pi by 6. What can be done over here? Let's see. Here cos is there. Cos 7 pi by 6. Okay. So we will be thinking about we need cos inverse. Outside is there. We can't touch that. Inside we are having cos of 7 pi by 6. Okay. So as we always know that if outside is cos inverse, then inside also has to be cos only. Okay. The inside function has to be cos only, then only we will be able to simplify it. Here it's already cos, but that is not working. So again we will think about changing this angle 7 pi by 6 so that like we will think about no transformation occurs which is on x-axis. Here 0 is there, here pi by 2 is there, here pi is there, and here 2 pi is there. And we know here on x-axis no transformation occurs. No transformation occurs. Okay. So we will be thinking about any angle just like pi plus theta, pi minus theta, 2 pi minus theta. These type of angle where no transformation occur, cos will remain cos only, and we'll be able to adjust this 7 pi by 6 also. So can I write this 7 pi by 6 as a maybe in the form of pi plus theta or maybe in the form of pi minus theta. Okay, so if we will be writing uh, pi minus theta, if we will be taking cos of pi minus theta, pi minus theta, that is coming in the second quadrant, and the result will be negative. Cos of pi plus theta, it's okay, negative positive, let's change. So can we write this 7 pi by 6 as a pi plus pi by 6, 6 pi plus pi, 7 pi by 6 cos inverse. Wait, just a second. If we will take pi minus pi by 6, it will be 5 pi by 6. And the result will be, and if we will take pi plus pi by 6, the result here over here will be minus cos pi by 6, and the result over here will be minus cos pi by 6. Okay, so can we say this and this it's same because both are giving minus cos pi by 6, right? Cos pi minus pi by 6 and cos pi plus pi by 6, it's the same thing. Cos pi plus theta, cos pi minus theta will give the same result if theta is same, right? Can we say?
Yes.
So here, this one can be written as cos of pi plus pi by 6, okay? Which is same as if we are having pi plus pi by 6, it's still, you can see, we can write it as, just a second, no? Yeah, pi plus pi by 6 we are having, which can be written as cos of pi minus theta also, because both the yellow one, it's the same thing, both are giving the same result, that is minus cos pi by 6. Okay, so cos pi plus theta can be written as cos pi plus theta can be written as cos pi minus theta. Why I am doing so, no? Because when you will write it in the form of pi plus theta, still you are having the answer as a 7 pi by 6. Okay, we are having cos inverse cos 7 pi by 6. Okay, now if you will write this 7 pi by 6 as a cos of pi plus pi by 6, cos inverse outside, still there is no use of this breaking. Pi plus pi by 6, what it will give? Nothing. We can see here cos inverse cos will get cancelled, still we will be left with 7 pi by 6 only. Okay, so what we are going to do, we are going to write it as a, this one is same as cos of pi minus pi by 6 also. Okay, we are going to use this concept, and hence cos and cos inverse and cos will just remove each other, and we will be having pi minus pi by 6, that is 6 pi minus pi by 6, and the answer will be getting 5 pi by 6. Let's see whether this option is there or not. Yes, 5 pi by 6 will be the correct option. Are you getting it?
Ma'am, can you go over this again? It's a little confusing.
When we are having cos inverse cos of 7 pi by 6, I want to break 7 pi by 6 and I ended up writing pi plus pi by 6. Is it clear so far?
Yes, ma'am.
Okay, now cos pi plus theta will be minus cos theta. I don't want to create negative over here. Okay, we want to have cos inverse cos only, no negative or nothing. Okay,
Okay, ma'am.
so that's why now to negative taking is not an option. So now we are thinking about other approach. So we figured it out that cos pi plus theta and cos pi minus theta, it's the same thing, like both gives the same result, so we can think that both are just same. So instead of cos pi plus theta, we can also write cos pi minus theta, right?
Yes, ma'am.
Because in both the angle, no transformation occur, and both gives the negative result. So we have taken pi plus pi by 6 as a pi minus pi by 6, same thing. Can you see the step over here?
Yes, ma'am.
And then cos inverse cos just removed each other, and we ended up having pi minus pi by 6 only. Okay, which is giving us angle 5 pi by 6. Now it must lie in this range. That's why the whole story started, that we cannot take 7 pi by 6. Can we take 5 pi by 6? Let's check. 5 into 180 by 6, 150. This means 0 to 180. So 150 lies in this range, and hence we can take this value. Is it okay?
Yes, ma'am.
Similarly, if we are having one more question, not like this, the other concept is there. Sine of tan inverse x mod x less than 1 is equals to option A 1 by under root 1 minus x square. Option B, 1 by under root, okay, here x by under root 1 minus x square. Here option C, 1 by under root 1 plus x square, and option D, x by under root 1 plus x square. What to do over here? Sine of tan inverse x. What can be done over here? Sine of tan inverse x. Anyone? Any idea what to do over here? Just a second. Yeah, any idea what to do over here? Just can we take this tan inverse x as theta? Okay, that means tan theta is equals to x. And in class 11, when we used to have such trigonometric function, what we used to do, we used to draw the right angle triangle where theta we used to represent. Tan theta means opposite over adjacent. So can I say opposite is x and adjacent is 1? Why suddenly I started taking this approach? Can you see the options? Can you see? That's why
Yes.
I started taking this way. That by doing anything, this type of answer may be like how we will get. So maybe by taking it like this, we will land up to such answer, which is given in the option. So tan theta, it's given as opposite over adjacent, opposite side is x, adjacent side is 1. What will be the hypotenuse? Hypotenuse will be the sum, that is x square plus 1. I can see in the option x square plus 1 is still there. Okay, what will be sine theta? Sine theta formula is opposite over hypotenuse. Hypotenuse. So opposite is x. Hypotenuse is under root x square plus 1. Okay,
Ma'am, but how are we assuming that the adjacent is 1?
because tan theta is x. Tan theta is x. That means tan theta is x by 1.
Okay.
Okay, if any number is like if I am saying x is 2, so that means you can also assume x is 2 by 1, right?
Yes, ma'am.
So we got sine theta as a x by under root x square plus 1. Okay, so we are having sine of tan inverse x, sine of tan inverse x. Tan inverse x I assume as a theta, which became sine theta, and sine theta now only we found as a x by under root x square plus 1. Let's check whether this option is there or not. Yes, option number 4. Just give me a second now. Let me have some water. Okay, so let me check whether any other important question is there from this section or not. No, we are done with the concept of inverse trigonometric function. Now we will be starting the next chapter, that is it matrices? Yeah, we will be starting the concept of matrices. Just a moment. Okay, so the basic concept from matrices you must know, like how to get check the order of matrix, and like what is row, what is column, how to do the multiplication, how to do the addition. I'll be taking questions over here. So the very basic question from this part, if I am taking the first question from the matrix chapter. So if the question says a matrix have 12 elements, the base, like the very basic concept is this one. What are possible orders it can have? Who will tell me what are the possible orders it can have if there are 12 element? Yes, anyone? Yeah, all are leaving. We are having just 5 more minutes. Let's start this one. We'll be continuing this chapter in the next class.
Okay, ma'am.
Okay, don't worry, I'll not take more time. So what are the possible orders? Possible orders can be, if there are 12 element, so how many element, like what are the possible order if we are having
Ma'am,
a,
6 orders.
if we are having a matrix, let's say the elements are 2, 4, 6, 7 and 8, 5, 2, 3. How many rows are there? 2. How many columns are there? 1, 2, 3, 4. 4 columns, right? How many elements are there? 1, 2, 3, 4, 5, 6, 7, 8. How we will get the number of element? By doing the multiplication also. 2 into 4 is 8. 8 elements are there. So if 12 elements are there, the possible order means m into n. Okay, so the possible order can be 1 into 12, 1 row 12 column, or it can be 2 into 6. Okay, 6 into 2 can also be there. 3 into 4 can be there. Okay, so these are the possible orders. Order means m cross n. So in this format we are breaking this 12. Okay, similar, 2 into 6 is there, 6 into 2 can be there, 4 into 3 can also be there. And what else? 1 into 12 is there, so 12 into 1 can be there, right? So these are the possible order, that is m cross n format, which can be there. The number of row can be this, the number of row column can be this, and hence we will be having 12 element. Or the number of row can be 2, the number of column can be 6, and hence we will be having 12 elements. So these are the possible orders. Are you getting it?
Yes, ma'am.
If the question says construct a matrix A, where A is given as Aij 2 cross 2, where Aij is equals to I plus Z by 2. Okay, if this condition is given over here, then we have to make a 2 cross 2 matrix. That means 1, 2, 3, 4. There are 2 rows, there are 2 columns. We have to fill the blanks according to the given arrangement. Now we know the first element is called A11, the next one is called A12. Here it's in the second row, it's called second row, first element. Here it's called second row, second element, just like this. Accordingly, we will be finding each and every value from here. Okay. So A11 will be 1 plus 1 by 2. That means 2 by 2. That means 1. It is 1. Now A12, it will be 1 plus 2 by 2. That means 3 by 2. Okay, A12 became 3 by 2. A11 became 1. Similarly, we will be just taking out A21. From where I am doing this, you can see this relation is given. Just I am putting the value of I and J. Okay, so I is Aij format is maintained over here. So I is 2 over here and J is 1 over here. So still we are getting 3 by 2. And then A22 will be finding. So I is 2 over here and J is 2 over here by 2. That means 4 by 2. That means 2 will be getting over here. And hence our matrix A is this one. Matrix A we got 1, 3 by 2, 3 by 2 and 2. Is it clear? Is it
Yes,
clear?
ma'am.
Okay, I'm keeping it this much. We'll be continuing the concept of matrix in the next class. When everybody will be there, I will be taking more questions.